So in this session we will be discussing a solved example for support vector mission. Here in this example we have a data set in which we have three features. One is district, the next one is x1 which represents vote percentage, and x2 represents youth score, and finally we have the label outcome as y. Now here in this table we have the district Chennai, which have vote percentage is 38 and youth score is 9.5. That results in the TVK party which wins in the region. And similarly the Coimbatore with x1 and x2 given points, it wins the label. This is already the data which we have. And Trichy is a district with 30 is x1 and 7.5 is x2. It wins the election. Similarly, we have Salem, Vellore and Viluppuram. The Salem, Vellore and Viluppuram is having x1 and x2. That results in loss of the election. So now the question is, we have to classify whether the district Madurai with x1 and x2 value will win the election or not. Now we have to check whether in Madurai with the score of x1 and x2 the TVK will win the election or not. This is the question. So based on SVM we have to solve the problem, as we have seen the theoretical concepts of SVM in the last session. If required you can check that video and then you can come back here in order to understand this. First let us plot the given values in the graph. So the first value I have is 38, 9.5. So approximately we will have 38 here, 38, 9.5. So it will be here, this Chennai. Let us have this Chennai. And the next thing is Coimbatore, 33, 8.5. So 33 and 8.5. We will have it here. And Trichy is 37.5. We have 30 here and we have 7.5. And here I have Salem 22, 5.0. 22 and 5.0. We have it here, 22, 5.0. And for Vellore I have 18, 4.5. I have 18 and 4.5. Here it is 12 Viluppuram with x2 is 2.5. 12 and 2.5. I have 12 here, 12, 2.5. So here I have the negative labels, the loss of the election here, the 3 points which represents loss, and here this points actually represents the positive win points. So if I want to divide this to class labels, win and loss election, then I should draw a boundary line. This is an assumption. I'm going to draw a boundary line. So this is nothing but a boundary line. It's a hyperplane which divides these two class labels, and I can draw the margin lines to the left and right of the boundary line. Right. So this is left and right. Now if I want to write the equation for the boundary, it is Wx plus b equals 0, and the boundary line, the margin line equation is Wx plus b. It is nothing but it is greater than or equals 1 since it is positive. And for the negative margin line we can write it as Wx plus b. It is equal to minus 1, or you can take it as equals plus 1 and equals minus 1. It is also correct. Now if I talk about this with margin with line, then it is nothing but W equals 2 divided by the magnitude of the vector W. this is how I can plot the given points, and I have divided it. Now we have to classify whether this x1, given x1 and x2 wins the election or not, right? They have given x1, x2 and the district. You have to find whether this wins the election or not. For this, we need the exact equation of the boundary line and the margin lines, so that I have one common equation in which the x1 value and x2 value of the new sample which needs to be classified can be applied, and we can check whether it goes beyond +1 or it falls on the negative margin line. If it falls on the positive margin line, then we can decide it as it wins the election. If it falls on the negative margin, the results of that, after applying x1 and x2 value in the equation, if you are getting the value lesser than 1 or it falls under the negative margin, then obviously we can classify it as it lose the election. So first let us find the support vectors, right? As I said, this is the support vector which helps us to draw the margin lines, right? These two vectors are nothing but this positive represents Trichy, and this negative support vector represents same. These are very close to the margin lines, so we are taking these two as the support vectors. So let's write for the clarity what is the so this is Salem, we have 22 5.0 and we have -1, and Trichy we have 30 7.5 and +1. So these two are nothing but the support vectors which are very closer to the boundary lines where we have drawn the margin lines through the support vectors. So let us take these values as x1 and x2 in order to find the equation of the boundary line. This boundary line equation should be identified so that I can apply x1 and x2. Whatever the new sample is given, the x1 and x2 value can be applied on this and I can find the value of it. Now let us take 30, 7.5. That represents +1, right? This is x value 30 and 7.5, and this is a y, x, y. And for Salem we have 22, 5.0 -1. So this is nothing but the x2 value, and this is y2 value, right? So now let's take W x1 plus B equals 1. This is nothing but the win margin equation as we have discussed already in the previous video. And here we have the next equation, W x2 plus B equals -1. So this is nothing but the last margin, it is negative margin. Let me take this as equation 1 and this is equation 2. Now the thing is, I'm going to find the value of this B, right? And also I should find some other parameter values which helps us to derive the boundary equation for the given data set. Let's see how we can do that mathematically. Now I have to perform equation 1 minus equation 2, which results in W into x1 plus B minus W x2 plus B equals 1 minus of 1. In this case, I'll take W which is very common. Alright, if I elaborate this, I'll get x1 plus B minus W into x2 minus B equals 2. So let me cancel it out. So I'll take W into x1 minus w into x2 equals 2, right? So here both w is common, I'll take that common term outside, so x1 minus x2 equals 2. So let me make it as equation 3. Here in this equation 3, this mathematically tells us that this w and this x1 and x2 are positive, right? So if w is negative, then w1 minus w2 will also negative. So it concludes that this w and x1 minus x2 are moving in the same direction, right? That's why we are getting a positive value here. So it moves in the same direction. So mathematically, if two different vector points are moving in the same direction, then one vector is said to be just a scaled version of the other. So why I am saying this, why I have to scale it, the scaling actually helps us mathematically balance out exactly plus 1 or minus 1 at the edges. If the points or your margin lines are somehow deviate from that, the scaled version will make it probably sit on plus 1 or minus 1. So that is the advantage of the scaled version. So if I take this and write as w equals a is nothing but a scaled version. So I'm going to fix the scaling factor as a with the name a into x1 minus x2. So since w and x1 x2 are moving in the same direction, I'm making this x1 and x2 as a scaled version of w. So w equals some scaled version which is represented by a. I don't know the value of a yet, but I have to find it based on the given sample. So a into x1 minus x2, the scaled version of w. Alright. And this is equation 4. Let me make it as equation 4. Now I have to substitute the value of, I have x1 and x2 value. With the help of x1 and x2 value, I am going to find the value of w. So x1 and x2 in 4. So let us substitute it. What is x1 and x2 value? We have the values of x1 30, 7.5 and 22, 5.0. We'll directly apply here. Right. So x1 minus x2 equals, it is 30 minus 22, and for x2 I have 7.5 minus 5. So here I'll get the value 8, 2.5. Right. If I apply this value on equation 4, I'll get w equals a into, what is x1 here? 8, and x2 is 2.5. So this can be written as 8a, 2.5a. Right. So I have the value of w, but here I have a scaling factor a. I have to find value of a so that I can conclude the final value of w here. So let's see how we can get the value of a using the available equations. So to get value of a, I should have w1 as 8a as per the equation here, and w2 is nothing but it is 2.5a. Right. So now I have two different boundaries. One is win boundary, the other one is loss boundary. First let us move with win boundary and find the equation for the win boundary first. So what is the equation we have? w1 or w into x1 plus w into x2 plus b equals plus 1. Right. So now we have the values of w as 8a, w1 value, right? If I take it as w2, I have the value of w2 as 2.5. Now I have to multiply it with x1 and x2. What is the win boundary x1 and x2 value? We have the win boundary as 30, 7.5. That is the win boundary. So it will apply it 30, 7.5. So 30 and 7.5 is x2. Right. Plus b equals 1. So if I get the value of this, I'll get 748 plus 18.75a plus b equals 1. So if I add up this two, I'll get 258.75a plus b equals 1. So this is the fifth equation we have. Similarly, we have to find for the loss boundary. If I go for loss boundary, I have the equation w1 x1 plus w2 x2 plus b equals minus 1, right? So here, as in the previous win boundary, we are going to apply the values of w1 and x1. Here I have w1 as 80 into plus w2 is nothing but it is 2.58. You have to get the value of x1 and x2 for the loss boundary. For loss boundary, we have the support vector here, Salem. It represents 22, 5.0. We'll take that here, 22 and 5.0 plus b equals minus 1. In this case, I have 176a plus 12.5a plus b equals minus 1. So if I add up this two, I'll get 188.5a plus b equals minus 1. This is nothing but equation 6. So I have the equation for win boundary and loss boundary. In both the win and loss boundary equation, I have a and b. So I should find the value of a and b so that I can get the final value of the boundary line equation. For that, I'm going to subtract equation 6 from equation 5. So what is equation 5 and 6? I have 258.75a plus b. Right, this is the equation 5. We got it. Minus, we have loss boundary as 188.5a plus b equals 1 minus of 1. We are subtracting this two win and the loss boundary equation so that we can find the boundary line equation with the help of value a and b. So now if I solve this, I'll get 70.25a equals 2. So now if I want to derive value of a, 2 divided by 17.25, which approximately gives you the value of 0.0284. So this is value of a. So with the help of win and loss boundary equation, we found the value of a here. Now we have to find the value of b so that we can apply it and get the boundary equation value. We have w1 value, we have w2 value, we have x1 value with this, x2 value with this, and also we have y1 and y2 is the class label. Now we have found a value also, the leftover is b. So we'll apply the value of a and get the value of b directly. We have w1 as, what is the value of w1? We have 8a and w is 2.5a. We will apply a value over here so that we can find value of w1 and w2. So w1 equals 8a and w2 equals 2.5a. So for 8a we get 8 into 0.0284. And here it is 2.5 into 0.0284. If I calculate this, I will get 0.228. Here I will get 0.07. Right. So now I have all the values with me for calculating this w1 and w2. From this, how I can find the value of b? I should have 30. So here I have 30A, right? Yes, I'll take this value here. 30 into A is 0.0284 plus I have 7.5 into 0.07. So W1 x1 plus W2 x2 plus B, it's equals plus 1 when it comes for the positive margin. I'm taking the positive values. What is the support vector of the positive value? It is 30 and 7.5. So I have taken 30 and 7.5 and I have used it here. So this is x value, this is w value, x1 w1, x2 w2, this is b, this is for the positive margin. So here I have taken only the positive margin because if I'm going to find the boundary line, and once I have found it, we have to apply x1 x2 value over there, and if it goes beyond 0, right, or beyond plus 1, then we can conclude it as will, and if it falls below 0, then we can conclude it as, below 1, then we can conclude it as loss boundary. So that's why I have taken here a positive boundary directly. So if I calculate this, I'll get 7.3725 plus b equals 1, and b is nothing but 1 minus 7.3725. So thereby I am getting minus 6.37. Got it. So I have got value of A, value of B, W1, W2, X1, X2 and X1, X2 for both positive and negative. With the help of this, I can directly write the boundary line equation that helps us to classify the new samples. So how I can freeze this boundary line equation now for the TBK party from the given equation. So now I have W1 value as 0.228, right? This is value of W1 which we have already found. This is the value of W1 we have found 0.0284 into X1 plus what is W2 value? We have 0.07 as W2 value X2 plus B, right? W1 x1 plus W2 x2 plus B equals 0. That is the boundary line. I'm just substituting the values on it. So the value of B is 6.37 equals 0. Since it's a boundary line, we have the value is 0 on the right hand side because it doesn't have any labels to classify. So we'll get 0 there. So now if I write this 228x1 plus 0.07 x2 minus 6.37 equals 0. This is the final boundary line equation which I have derived from the given data set. So for TBK party, I have this boundary line equation, and if I give you any distinct value of x1 and x2, x1 is what percent and x2 is its score. So with the help of that x1 and x2, you can directly apply the value of it here, and you can get the value whether they will win the particular district or not. So now see what is the sample that is given to you to classify. We have x1 is 20 and x2 is 6.0. 20 and 6.0. We'll take it as 20 and 6.0. 20 and 6.0 are the two values given for the district Madurai. We have to find whether this Madurai with x1 and x2 value wins the election or not. Whether TBK wins in Madurai district or not. We can apply this value directly in the boundary equation. So we have 0.228 into 20 plus 0.07 into 6 minus 6.37. We have to check what is the value of it. So this is 0.228 into 20 gives you the value 4.56 plus, and here 0.07 into 6, it gives you the value 0.42 minus 6.37. Okay, solve this, I'll get 7.56 7.56 plus 0.42 gives you the value 4.98. 4.98 minus 6.37. It's nothing but minus 1.39. Thereby it concludes that TVK will lost the election in the Madurai district. Alright, this is purely based on the given data set. We have found the boundary line equation, and whatever this new sample that is given for you for the classification, you can directly apply it on the boundary equation. Just apply the value of x1 and x2 in the boundary equation, you will get the result. And now let's have a simple thing to conclude. As I said, the margin width can be calculated by 2 divided by the magnitude of W. So now I have values of W1 and W2 in my hand. So I'll show you how to solve this. So square root of W1 square plus W2 square. Wait. So I have the values of W1 square. What is the value of W1 here? 0.028 and W2 is 0.07. That's what I have to apply here. 0.228 square plus 0.07 square. If I solve this, I will get 8.37 units. So this is nothing but the margin width. As I already said in the previous video, the margin width should be the longest, largest width will be freezed as a margin width in order to make your classification very clear and accurate. So according to the given samples, the margin should be freezed with 8.37 units. Right? So that's all for today. Thank you.